Assalamualaikum everyone. Welcome to my final defense project showcase. I'm Fozia Fariatura, ID 192.1513357. My project title is Predicting Gene Regulatory Networks in Seed Development using Deep Learning. For this project, I used Python as primary programming language and Anaconda Navigator and Visual Studio Code as IDE. My proposed algorithm also utilizes the CUDA core of NVIDIA GPUs and faster results. Here is my project directory in Visual Studio Code. My root project directory is divided into two subfolders, code and data. As the name suggests, data subfolder stores necessary data for the experiment and the code subfolder holds all the necessary Python codes for my method. Inside my data subfolder, there are 5 CSV files containing expression data for Arabidopsis thaliana, reference network, trend set, test set, and validation set. You can identify these datasets by their names. In my code, there are 4 code files and 1 configuration file. Amongst the 4 code files, utils.py file is set up the dataset by loading relevant Python libraries and calling dataset from specific directories. There are also functions written for calculating accuracy of result in this file. Layer.py converts loaded text data into graph data so that we can use graph neural network framework and graph attention network reads this graph data and converts it into relevant graphical forms. Model.py implements my proposed model. In this file, I implemented the codes for encode and decoder for the neural network architecture. There are also methods for graph convolutional network and graph attention network, which are essential in my method. Train.py uses the flow of past tree files sequentially in order to train the method and produce results. This file calculates loss val, loss test, ACC val, ACC test, ROC, AP, ROC-SKL prediction values. Additionally, param.yaml file regulates the parameters of this project. My proposed method is able to use both CPU and GPU of a computer system, enabling fast results. My coder runs up to 900 epochs and displays training loss, training accuracy, and time spent. Finally, after 900 iteration, it shows the average loss of test, average loss on train, accuracy of test, AUC of test, and AUPRC of test. That's all of my defense project showcase.